Today we are going to look at progression. It's also referred to as sequences. We are looking at arithmetic progression. That is AP for the start. Let us refresh our memory. We know that in arithmetic progression, the general form or the standard form of an AP is A plus D, A plus 2D, and it goes on like that, ellipsis, until the last term, which is A plus M minus 1 times D. The first term here is the A, and the common difference is D, and the number of terms is N. Our D, which is the common difference, is calculated by subtracting the first term from the second term, or subtracting the second term from the third term, and so on and so forth. Usually we also find the n term of a geometric progression, of an AP. The n term of an AP is calculated using the formula Tn, where n here is a subscript. That is to say, the n term of this AP is equal to A plus M minus 1 in bracket open and closes times D. The third point here is the sum of n terms of an AP. How do you find the sum of n terms of an AP? There are two possible formulas we can use. The first one is the sum of n terms equal to half n into A plus L, where the L here is the last term of that progression or sequence. And that last term is calculated by A plus M minus 1 times D. The last term here also is the same thing as the n term. So Tn and L, they are actually the same. Or we can find the sum of n terms of an AP by using the formula Sn equal to half n into 2A plus M minus 1 times D. So we have refreshed your memory now on some of the key facts that we are going to use in arithmetic progression. Let us now take an example. Our first example is find the sixth term of an AP whose first term is 2 and the common difference is half. Solution. We are looking for the sixth term, so Tn is equal to A plus N minus 1 times D. Your A in this case is given to you as 2 and the difference is given to you as half. And you are looking for the system N equal to 6. So our T6 is equal to 2 plus 6 minus 1 times half. The result of this is 2 plus 5 times half. And then of course that is 2 plus 2 and a half. And that will be equal to 4 and a half. So the system of this progression is equal to 4 and a half. Example 2. If the ninth term of an AP is 5 times the fifth term, find the relationship between A and D. Solution. The ninth term of an AP is A plus 8D. And then the fifth term is A plus 4D. And we are told that the ninth term is 5 times the fifth term. So A plus 8D is equal to 5 times A plus 4D. Now, we want to find the relationship between A and D. Let's solve this. We now have A plus AD is equal to 5A plus 20D. Meaning therefore that our A minus 5A is equal to our 20D minus 8D. Minus 4A is equal to 12D. So the relationship therefore is either minus 4 equal to 12D or can say 4a is equal to minus 12d. Whichever one, they both are correct. But we can still go ahead and divide both sides by 4. That becomes a is equal to minus 3d. This is a better result compared to the first one. Let's take example 4. If 3sy24 are in AP, find s plus y. Solution. Now let's take a look at this. You know that in an AP, the common difference will be the same. And that's why they say it's a common difference. So how do we get the common difference? Our s minus 3 will be equal to our y minus s, and that will be equal to our 24 minus y. Using this expression, we can now have s minus 3 is equal to y minus s, and of course, we have that our y minus s will be equal to 24 minus y. In the first case, we have that our s plus s minus y is equal to 3, giving you 2s minus y equal to 3. This is your first equation. Then we do the same thing for the second one, where you have y plus y minus s is equal to 24. This is 2y minus s is equal to 24. We have the second equation. With this equation 1 and equation 2, we can therefore find the value of s and y by solving the two simultaneously. In this case, you have your 2s minus y equal to 3, and in the other case, you can multiply by 2, that will be 4y minus 2s, and is equal to 48. Multiplying the second equation by 2. So we have already said equation 2 times 2. Now, with these two equations, you can subtract 2s. You will now add. You add the two equations together. 2s minus 2s will be 0. Minus y plus 4y will give you 3y. And then, of course, 3 plus 48 will give you 51. Therefore, your y will be equal to 51 all over 3, and that is 17. Then you can now get the value of your s by substituting in any of the equations. Let's substitute in equation 2. So we have there 2y, which is now 2 times 17. 2 times 17 minus s is equal to 24. Therefore, solving this one, you have 34 here, and then of course that becomes 34 minus 24 is equal to your n. And so your s in this case is equal to 10. So we're looking for s plus y, and that means 10 plus 17. And the final answer is equal to 27. So in this case, we have been able to find the value of s plus y, which is 10 plus 17, equal to 27. Example number 5. Find the sum of the first 20 terms of the arithmetic progression log a squared, log a cubed, ellipsis. Our solution. To find the sum of an arithmetic progression, we say Sn is equal to half n into 2a plus n minus 1 times d. This is a situation where you don't know the last term, so you use this formula. Now, our n is equal to 20. Our a is equal to log a. Then our d, which is the common difference, is log a squared minus log a. Now, this will give you log a squared all over a, and then this is equal to log a. You can now substitute the values in the formula. So our S20 will now be equal to half times 20, and then this is 2 times a, which is 2 times log a, and then of course you have plus 20 minus 1 is 19, multiplying log A, the common difference. Now that you have this becomes your 10, and of course this is log A squared, and then this is plus log A also raised to power 19. Now this becomes 10 multiplying log A squared times A raised to power 19, applying the rules of logarithm. This becomes 10 into log A raised to power 2 plus 19 is 21 by the laws of logarithm or the theory of logarithm. And this of course will be equal to the logarithm of A to power 21, and then again this is to power 10, which eventually becomes the logarithm of A to 210. And of course we can see that this one as equal to 210 then log A. 210 log A. So whichever one, you can take this as the answer, and this one is also correct. Both are correct. Example 6. The sum of the first n terms of an arithmetic progression is 252. If the first term is minus 16 and the last term is 72, find the number of terms in the series. Solution. Here we are given the last term, so that will advise you on which formula to use. So Sn is equal to half n into A plus n. This is now the formula you are going to use to find the sum or the number of terms, n. Now, the statement says that the sum of the first n terms of an arithmetic progression is 252. So the sum of the first of the n terms, 252, equal to half times n, and here we are told that the first term is minus 16 and then the last term is 72. Now let's simplify this. You can cross multiply. This gives you 4, and that is 10, and that is 504 equal to n multiplying. Take away this from that, if you minus 16 plus 72 will give you that is 6, and then of course this one is equal to 556. Therefore, our n is equal to 504 all over 56. So find the value of 504 all over 56. That will give you 9. This is equal to 9. And the case is that will be equal to 9. Therefore, the number of terms you are looking for is equal to 9. Example 7. If the seventh term of an AP is twice the third term and the sum of the first 4 terms is 42, find the common difference. Solution. The seventh term is A plus 6D. And this one is twice the third term. The third term is A plus 2D. In other words, we have A plus 6D is equal to 2A plus 4D. And that means 6D minus 4D is equal to 2A minus A, giving you A is equal to 2D. You can call this your first equation. And he went further to say that the sum of the first 4 terms, S4, is equal to half times 4 into 2A plus n, which is 4, minus 1, which is 3, times D. And they said the sum of the first 4 terms is equal to 42. This is equal to 42. You will simplify this. 2 will cancel, and the 2 will now divide all through. You now have 2A plus 3D is equal to 21. This is the second equation. You will therefore now solve equation 1 and equation 2 simultaneously, and then it will give you your A, or rather your D, will be equal to the value 3. solving equation 1 and equation 2 simultaneously. All you need to do is to put your A, which is 2D, into this value here, so it becomes 4D plus 3D, and that is 7D equal to 21. Therefore, your D is equal to 3. You will have solved the problem. Here are the exercise for the arithmetic progression that we have just treated. Question number 1. Find the 10th term of the arithmetic progression 18, 12, 6, 0, minus 6, ellipsis. The options A, B, C, and D are also there. Number 2. If the sixth term of an AP is 11 and the first term is 1, find the common difference. You have the options A, B, C, and D. Number 3. The sum of 8th and 9th terms of an AP is 72. And the fourth term is minus 6. Find the common difference. Options are also there for you. Question number 4. If minus 8, M, N, and 19 are in AP, find M, N. The options are A, B, C, and D. Number 5. Find the nth term of the sequence. 5, 8, 11, 14. A, n into m plus 1, B, 3m plus 5, C, 3m plus 2, D, 2m plus 5. Number 6, find the sum of the first 11 terms of the arithmetic sequence whose first term is 2 and the common difference is 3. You have your option A, 157, option B, 187, option C, 197, D, 200. Here are the answers to the problem. Number 1, A is the correct option. Number 2, D. Number 3, D. Number 4 is A. Number 5, C. Number 6, B.